in this video, we will cover filaments and filament advection workflow in Popnet in Houdini, and then kind of ditch our default filament solver and make our own custom solver. So let's begin by dropping a geonode. Inside, drop a sphere. Make it polygon, frequency 60. Then let's project some UVs on it. We want these to be polar. Yeah. Next, an attribute from map. I don't know, it's just me, or like, does this node take a long time to load for everyone? It's kind of slow, yeah. So let's go with this one. Load. Color. I'd like to make a few adjustments to the color and kind of get rid of these dark parts, and let's do this with an attribute of. We'll do some color correction here. Drop an RGB to HSV. If you want to see what HSV looks like, here it is. It's kind of weird and unique and fun, but let's just stick to RGB for now. So let's drop a vector to float and then float to vector. Then HSV to RGB again. So we have our RGB color spot. So for this part to not be so dark, let's adjust its value. Drop a constant and let's keep it 1. So now all the points on this geometry have a color value of 1 and incoming hue and saturation. So let's also modify the saturation a bit. Let's do it 0.8. Yeah. And maybe point. Next, a mountain node. Animate noise. So this will be your emitter geometry. Drop a Popnet and plug this in. Also drop a sphere. Let's change it to polygon and frequency 1 and plug in here. Now inside of Popnet, let's drop our filament nodes. Filament source, filament solver, and advect by filaments. This connects, I think, here. So yeah, nothing's happening because we haven't assigned the geometry to it yet. Let's do it. Pointing to our second input on this sphere right here. So you can see it's loaded up now. Still nothing, because here in bindings, this node is not working on, but this node is kind of like, how do I explain this? It's kind of initializing the data name for this incoming geometry. Yeah. So let's call it filament. So we can tell Houdini to work on this data type independently of our other geometry, which is particles. Also here, let's change this to filaments. Oh no, let's keep this to geometry. Change this to top data. Here we type in filament. This is the type of data that the node wants to import, and this is the data that it will be working on, the particles. It will advect the particles. So geometry and filaments. Velocity scale 5, and this would be pop object. This thing here. So, and for filament solver, here again bindings filament. Now if you press play, you can see this is working now. Now if you just mess around with the settings, like you can see there is some control, but not a lot. Yeah, like very sensitive settings and not really that fun to play with. Same with the solver. Nothing's really here that's like worthwhile. So let's get rid of this and drop a sub solver. Let's create our own. And this, in my opinion, would be much more interesting than that default one. Let's change here to filaments and go inside. Get rid of these, don't need them. And drop an attribute warp. So if you saw what was happening was, it was kind of taking these individual faces and displacing them along the normals while kind of moving them in weird ways. And maybe there was some resampling going on. So that we can use that as a guide as to what we have to do in here so that it kind of, works. So inside, let's take care of displacing these spaces along their normals. To normalize, this gives us the direction of the normals. Then a curl noise, calculate its length. This gives us the magnitude of this curl noise. Then multiply. And this vector now has the direction of our normals and the magnitude of our curl noise. So let's add this to our current point position and plug this in. Now you can immediately see that it's going crazy. So let's set the amplitude of the noise to 0.01. Yeah, seems fine. Let's go up. And now you can see nothing is happening because we did not disconnect these individual faces. So it's kind of displacing the whole geometry. But as we can see, it clearly needs individual faces to work. So we can fix this by going here in geometry context and dropping a facet node. Yes, facet. Kind of forgot its name. Okay. Unique points, check unique points. And now it's working. As you can see, it's not like that boring old motion we were getting from the filament solver. We can still get this if we, instead of this, do a constant. Let's 0.1. Now it will move along the geometry and kind of give you the similar motion that was there before. Yeah, like what was happening with the default filament solver. This is kind of the same behavior. Also, let's optimize this a bit. We don't want particles to emit all the time, because once these filaments have moved away, they have really little to no effect on the points here. So we want to emit until maybe, let's say, frame 70. So in constant activation, drop this expression. So this is telling Houdini that if the frame is less than or equal to 70, emit particles, otherwise don't. And let's change this to 10,000 constant birth rate. Okay. Now also inside this solver, let me just color it a bit so it's easier to spot. Let's plug this one back in. Or we can also add this and kind of like, so basically inside this sub solver, whatever you do to move these faces around will reflect on the movement of particles. So if you were to, let's say, drop a transform and we want to rotate it in y-axis 1 degree every frame. So now it's rotating along y-axis. Let's see what it does to the particles. Yeah, you can see it's kind of having an effect on them. Also not enough particles. Okay, because I set to 1000 instead of 10. So you can get some really cool results from this workflow. So let's go ahead. Let's tweak this a bit and let's set a frequency of 2 so there's a bit more movement. And suddenly you can see the particles are behaving quite differently. The solver, in my experience of like 5 times I've played with this, is quite sensitive. So you'll have to be a bit patient with it and like move the values of the noise and all that just a little bit at a time. Let's get rid of this. And there's what else can we do? Let's set a random offset something. Turbulence, okay. Everything's good. And maybe 0.5. Let's see what happens. And now it's kind of rotating along an axis. And it kind of influences the points to move along as well. It's still moving a bit too much. So let's do it 0.005. Or maybe even lower, 0.002. So yeah, now it's kind of interesting. Also, let's change the offset a little bit. And let's for now pin this viewport so we don't have to jump back and forth all the time. We'll tweak these settings until we have something that I like. Let's try this. Yes, this kind of looks really nice. Let's go ahead with this. Also, another thing before I forget. So if you change these sub steps to, let's say, 3, what you will notice is the geometry kind of moves away thrice as much, kind of. Like on frame, let's say 48, you can see if the substeps are 3, this is the position. Let's change it to 1 and control click on this brain thing, and you can see that the movement in the geometry is quite accelerated. Yeah. So to fix this, what you can do is copy parameter this max substeps, and then just multiply it here, promote this parameter, and let's call it max substep. Kind of fumbling a lot today. So yeah. Also, nice idea to use underscores instead of spaces, at least in label. And let's paste our relative references. And I think I added it. That's not what we want to do. We wanted to divide. We wanted to divide, yeah. Sorry about that. So let's divide this. Paste relative references. And let's jump to frame 48. Now, if you can see, the effect of increased substeps is kind of negated. Let's check it. Drop this to 1 and control click. Yeah, now it's fixed. Let's keep this 2. Let's tweak this a bit. It's not really that good right now. Let's speed this up a bit. Yeah, now it's kind of looking a lot better. Let's go up. Drop a DOP import. For this, I want to import both the filament geometry and the particles. So drop import is the way to go. Here, let's just drop this here. Objects, we want pop object and geometry data path for this geometry. This is the name of our particles, and another one, this would be filament. So let's see what happened here. Okay, that's what happened here. Get this back. Yeah, the motion is kind of nice. Let's drop a bit of wind noise. Amplitude 1. This kind of gives a bit more variation to the movement of particles and kind of looks a bit more organic in my opinion. Could be particles, filament, merge, drop a 5 hash. And then I have named these, put these in separate groups and merge them so I can like cache them out in a single folder. So now we will split it again. Let's split our particles. Now you can see our particles are on input 1 and filaments on input 2. Okay. Why did it? Okay, now I'll just cache it out a bit and I'll see you guys as soon as it's done. So now the cache is complete. Let's play this and see what we have. It's kind of looking actually good. Particles we want on. Yeah, actually, for this to properly work, let's do one thing. Render particles here, and this we will paste another geo. This kind of makes it easier to render, assign materials actually. So I can just drag and drop and assign them. Now inside, don't need this, don't need this. Drop a standard surface and MTLX geom color node. Plug this in base color and change this from float to color. Yeah. And for filaments, same, delete these. Drop a standard surface. Let's keep it default for now. Let's do the same for DG. And 0, 0. Let's keep it black. I think it will look kind of good. Also, we'll need an environment light. Environment map, I can use this. This is just a plain radial ramp. I don't remember where I got it from, but okay. Camera one. Now let's drop a Popnet. Let's see what happens. Yes, you can see the particles. Now let's adjust the P scale of it. I want to adjust the P scale based on their velocity. So let's do this with an attribute triangle. And maybe get this one. Yeah, I said by velocity will be doing it by P, will be setting the P scale by speed, length of vector B. Yep. 0.001, too small, 0.01, still a bit too small, 0.1, 0.1 looks kind of fine. Yeah, 0.05 looks really good. Okay. Let's adjust our lights. Yeah, let's just keep it white. And inside of magnet, let's play with our filament now. What can we do with this? Let's make it a glass. For that, let's extrude them a bit. For this, we'll use a lab's thicken node. We'll do this just both directions and 0.01. Next, we want to do what? A polygon. That's too much. Let's give it 0.02 and increase the divisions to 5. Back to materials. Let's create glass. Am I doing this wrong? Just a second. I think I did not apply this material. Let's see. Yeah, I think I did not apply this material. That was the problem. So let's keep the specular to 1 and transmission also to 1. Keep this values default. Okay. Glass isn't really working out, so let's not do that. Mining material is always kind of a bit experimental in nature. So let's go ahead. What else can we do? Yes, it just sometimes refuses to update. Don't know why. So yeah, black isn't working out all that good. Let's just keep it white. And background, yeah, it's already black. I think it's looking quite all right. Yeah, it's looking good. So I'll just render the animation out, and if you guys have any feedback, any constructive feedback, please go ahead and drop it down in the comments. Or you can, if you have questions, you can also drop them down in the comments, or reach out to me on Instagram or maybe Twitter. I mostly use Instagram. Twitter is like a rare thing. I rarely use Twitter. So yeah,